Good morning, everybody. This is a live extreme weather briefing discussing the severe weather potential tomorrow afternoon and overnight. I still think it does look like it has tornado outbreak potential, even though the upper levels are a shearing out upper level storm system. I see a couple different modes of supercells with tornado potential that are going to play out tomorrow, even developing potentially as early to mid-afternoon with that initial mode that comes out of eastern Arkansas, northeastern Louisiana, spreads across northwestern Mississippi, and eventually all the way up into middle Tennessee tomorrow night as well. So I have to decide, do I want to get on that early mode that comes out of southeastern Arkansas, northeastern Louisiana, right along that moisture nose? That's the mode that I have identified there, a little bit further west. Or do I want to wait for those renegades that could form into the open warm sector where there is going to be a little bit more instability as well? So that's the decision making that I'm going to be going through. Do I target this mode out of the moisture nose? A cluster of supercells will be ongoing in the morning, tomorrow morning. Those will be likely over southern Arkansas to northern Louisiana. And as those track off to the northeast, there's going to be a moisture nose that's surging northward through the Mississippi River Valley, and once that moisture nose reaches up with that mode of storms, that's when they're going to have tornado potential. And it could be when they're just to the west of the Mississippi River Valley, maybe down toward the Monroe area, where there's going to be a ton of dew points, and those are just going to ride that moisture nose all the way off to the northeast as it lifts off to the northeast, eventually up into middle Tennessee during the overnight hours tomorrow evening. So definitely need to keep an eye on this across northern Mississippi into middle Tennessee. And then the HRRR model, which handles the low-level thermodynamics a lot better with these wintertime setups, especially across Dixie Alley, southeastern Great Plains, into the southeastern U.S. Basically, any nocturnal event is definitely better handled by the HRRR model. And it shows these renegade storms developing in a confluence line that often extends from southeastern Louisiana up through southern Mississippi, up along the I-20 corridor, up toward that Tuscaloosa, Birmingham area. And these renegades also could develop by middle afternoon, probably 3 p.m. type of a time frame. They'll develop down into southwestern Mississippi, southeastern Louisiana, and those are also going to track northeastward, potentially impacting the Jackson area, I-20, up toward Tuscaloosa and Birmingham. And you can see in the background map that there's going to be deeper moisture down available for these renegades, greater instability down there. Not as much surface convergence to initiate these, but there is that subtle confluence line. Not much of a capping inversion with that deep moisture this time of year during December. So I think that those are going to be easily overcome with that cluster of renegades that's going to evolve from southern Mississippi all the way up through the Birmingham, Alabama area. But also keep an eye on this moisture nose off to the northwest, southeastern Arkansas, northeastern Louisiana, down near Monroe, eventually spreading across northern Mississippi and eventually into middle Tennessee as well. So we'll have to keep an eye on that mode. And now I'm going to tell you a little bit in more detail on why I expect these different modes. And here is the loop of the HRRR model, Energy Helicity Index. I usually don't like to use these composite indices, but in this case, this is a very easy way to get a generalized look at how the surface-based instability is coincided with that low-level wind shear, the 0 to 1 kilometer storm relative helicity. And look at those yellows and oranges down into central and southern Mississippi that eject up through the Tuscaloosa and Birmingham area. That shows you just how volatile that environment is down there with those renegades down near that confluence line. You can see that those bright orange and yellows basically lines up right along that confluence line from southeastern Louisiana through southern Mississippi, eventually into central Alabama. That's an environment that even though that low-level jet is about 40 knots, that's not the 50 to 70 knot low-level jet that we saw with that December 10 and 11 event, for example. There is a lot of directional shear. That 40 knots is over top a south-southeasterly and a weak surface wind, so that's contributing to greater than 200 0 to 1 kilometer storm relative helicity. And that directional shear continues all the way up to 500 millibars, helping to encourage that more northeasterly storm motion. And also follow that moisture nose up into eastern Arkansas and northwestern Mississippi. Even though the instability isn't as great as that surges up toward middle Tennessee, it still is sufficient for that tornado potential. And there you can see those storms moving from southeastern Arkansas up into western and middle Tennessee. There they are in the morning right there. And I'll have to decide, do I want to get on that convection into northwestern Mississippi, maybe intercept it near the Tunica area, back into southeastern Arkansas? Or do I wait down near the I-20 corridor, down near Jackson? Look at that prefrontal confluence line, southeastern Louisiana up through the Jackson area, firing up those isolated bean-shaped supercell storms that lift up toward the Tuscaloosa, Birmingham area in the overnight hours and through the late evening on Wednesday evening. That's when that timing arrives up there. But anytime you see a weakly force, strongly sheared warm sector like this, the tendency is going to be for those isolated individual supercell storms. That's going to be the mode of convection, not a surging squall line that you often get ahead of those rapidly advancing Arctic air masses. But in this case, you get more of those prefrontal confluence lines, just gentle uplift, and that helps to force those bands of discrete supercell storms that are capable of moving in to the very strongly sheared environment. And as I mentioned, the trough of low pressure is relatively sheared out and not very high amplitude. There you can see it organizing over the southeastern Great Plains. And boy, did the NAM and European model do a better job with this system than the GFS model, amplifying that system over the southeastern Great Plains. You can see those red colors there along that trough from Oklahoma up across Missouri, Illinois. You can also see that system cutting off, though, off of California. See it right there in California? That upper level system is trying to close off of California and Baja, and then you can see that stronger system arriving in the Pacific Northwest. That system's going to dive south and slingshot that cutoff low off California and Baja off to the northeast, and that could set the stage for an even more substantial severe weather event on New Year's Day. There you can see the evolution of that low-level jet across the Mid-South. Even though this is a relatively flat upper-level system, the squeeze play between that subtropical ridge off the southeastern U.S. and any gentle trough is going to create a low-level jet that is sufficient for strong low-level wind shear. And here is the loop of that 0 to 1 kilometer shear throughout the period. That there is on Wednesday morning, tomorrow morning. See that low-level shear lift up and then meet southeastern Arkansas. Those modes that are coming out of south central Arkansas and north central Louisiana are going to hit that moisture surge as it surges up through the Mississippi River Valley, meets up with those storms, and those are going to probably be the early tornado producers at around 2 to 3 p.m. once they hit that moisture and then go surface-based. So I'm going to show you that right now, starting off tomorrow morning. This is the HRRR model. This is tomorrow morning, 6C HRRR. That'll work fine. So here you can see that moisture surge. See these upper 60s dew points? This is tomorrow morning at about 5 in the morning, 5 to 6 in the morning. You can see that moisture 69 dew point there in Alexandria, Louisiana, surging northward. Usually in the Mississippi River Delta, as you get a strong low-level jet, which we're getting from a preceding system. So that moisture return is happening right now. And you'll get a little bit of a moisture node surging up through the Mississippi River Valley, and that's going to reach up into southeastern Arkansas by the time those morning storms are going to arrive. Let me zoom in just a little bit so that I could show you what I mean by these two modes. And I identified these basically using experience with chasing these events and also looking at patterns in the preceding events before the big December 10 and 11 event. But watch here as we step forward 2 more hours and watch this moisture nose surge up into the Mississippi River Valley. There you can see that dew point up into 66 there just to the south of Tunica. And you can see these dew points just surging up through the Mississippi River Valley, up through Monroe. You got a 68 there by late morning tomorrow. And you're just surging up into the mid to upper 60s throughout the Mississippi River Valley. This is really your moisture surge right there. Once it dips into the upper 60s, you can see these deeper greens and blues there. Those are your upper 60s dew points that are surging up the Mississippi River Valley. You can also see these 70s dew points, though, moving in out of southeastern Louisiana into southern Mississippi. That's going to be setting the stage for big-time instability for that Renegade mode. But look at these dew points surging up through the lower Mississippi River Valley, reaching up there. That's the nose, the moisture nose that I'm talking about. And at the same time as that moisture nose is surging up through Natchez, Vicksburg areas, reaching up into the Tunica area, all the way up into Memphis, you start to get into those mid to upper 60s dew points. And then we're going to see this cluster of supercells moving out of this regime, eastern Arkansas into northwestern Mississippi, just as that moisture is surging northward through the Mississippi River Valley. Once that moisture reaches up with those storms, they will likely become surface-based and will have that tornado potential. So I am going to have to watch this mode across northwestern Mississippi. You can see that they do turn into supercells that move into Middle Tennessee. It's hard to tell if this initial mode will be more of a rainmaker or if there will be some embedded tornadoes in there. I do think that the wind shear is stronger for this area, and so I do think that there is going to be some tornado potential there into Middle Tennessee as well with this mode and back into northern Mississippi. The wind shear ejects off to the northeast as well. The strongest wind shear at least, but then look at these renegades starting to form down in the open warm sector. A lot of cape within those low 70s dew points, forming right at about 5 p.m., just prior to sunset, down into Jackson. And this mode is going to be dangerous because that is the mode that very likely could move up toward that Tuscaloosa, Birmingham area, that corridor. A lot of times this confluence band that basically extends from southeastern Louisiana, southern Mississippi, all the way up, eventually spreading into the Tuscaloosa, Birmingham area along that I-20 corridor. Those are what we're going to have to watch out for. This is at 6 p.m. Renegades developing even into west central Alabama by this time. Another round of storms moving into Middle Tennessee as well. And then the main front even convects a little bit back into Arkansas. But look at these bands. And even within the general confluence band from southeastern Louisiana into Middle Mississippi and Alabama, you still get individual confluence bands within that of these Renegade supercell storms. So that's at 7 p.m. There's your 0 to 3 kilometer wind shear. Let's take a look at the lowest levels. What is the lowest level wind shear matters the most, especially these yellow areas. So by about 7 p.m., your strongest wind shear extends from about Meridian, Mississippi, back toward Jackson, up through the Birmingham, Tuscaloosa area, up into middle and eastern Tennessee, even northwestern Georgia. So that's the area that's most favorable for tornadoes. And very dangerously, the models are forecasting these bands of Renegade supercells, southeastern Mississippi through middle northern Alabama, all the way up into Middle Tennessee. The wind shear ejects gradually, though, east of northern Mississippi and western Tennessee. So basically, you have to follow that mode of Renegades from the nose, southeastern Arkansas, northern Mississippi, up into Middle Tennessee. That's going to be about early afternoon to the middle to late afternoon, round after round of supercell storms. And then some additional Renegades develop as well, southeastern Louisiana moving into southern Mississippi, and eventually those track into central and northern Alabama with that, bringing with it that tornado threat, all the way up into northwestern Georgia even. Tornado potential. A lot of directional shear encouraging these largely due easterly storm motions. Let me get rid of my face there to show you what that photograph looks like. And this is in northern Georgia, near the Atlanta area, Wednesday late night. So this is late evening, like 10 or 11 p.m. And that is a nasty photograph. Your directional shear, because of the favorable shape of the system, bringing your mid-level winds more back over in this portion of the plot, that forces a near due easterly storm motion up there, and that's able to carve out a lot of low-level wind shear in the 0 to 1 and 0 to 3 kilometer layers, in excess of 300 0 to 1 kilometer SRH available to these storms, southwesterly winds at 1 kilometer near 40 knots. So that creates very large looped photographs. Even with that low-level jet of 40 knots, even though it's not 50 to 70 knots, it still does have a lot of directional shear available to it. Looking at a photograph back toward the Tuscaloosa area, definitely a little bit of an increase even in that 1 kilometer wind, and that east-northeasterly storm motion at about 40 knots. Plenty of wind shear, near 300 0 to 1 kilometer SRH available to these storms. And so this is looking like a outbreak tomorrow night. And I think that the SBC is going to upgrade to an enhanced risk, maybe even greater than that for this setup. Right now, the Storm Prediction Center maintained a large slight risk that has a large 5% area for tornadoes. An upgrade to enhanced was considered last night, including those significant probabilities for significant severe weather, but decided not to just last night. But I do think that an upgrade is going to be inevitable for this event, and I think that risk should even be expanded into Georgia, into northern Georgia. Eventually, that favorable wind shear even spreads into upstate South Carolina. in the middle of the night hours. This is a shearing out, relatively progressive, fast-moving system. And it looks like there is just a little bit too much in the way of stable air to the east of the Appalachians. I could show you this stable profile, thermodynamic profile there with those temperatures into the 60s, even though it is relatively warm out here. Just a little bit of a wedge of stable air might prevent that severe weather from moving all the way to the upstate Carolinas, at least with this system. But I do think that the January 2nd system has greater potential to bring that severe weather further east into the southeastern U.S., which we're about to take a look at that system as well. Just for fun, we could look at the updraft helicity values. So this is during the entire run of the HRRR, and it does hint at these individual confluence bands and the northern nose. It does seem like, at least if you go according to these updraft helicity tracks, which I'm not as much of a fan of these updraft helicity tracks as anything. I like to look at the environment that these storms are moving into, the magnitude of the low-level jet, the shape of the upper-level system. But this does, in general, show these two different corridors, one from southeastern Arkansas across northwestern Mississippi into middle Tennessee, Nashville. This is why you got to keep a close eye on that moisture nose mode, right along that moisture nose that initially surged northward through the Mississippi River Valley and then continues to surge just ahead of a very subtle surface low. Or do you play these renegades? And you could definitely see a hint at the updraft helicity for those renegades that also would take those supercells into the Tuscaloosa, Birmingham, Alabama area. So let's take a look at the difference between 6Z and 12Z, and notice how these updraft helicity markers are even more favorable. But run to run from 6Z to 12Z, it still has this moisture nose mode up there from southeastern Arkansas all the way up to middle Tennessee, hinting at some long track supercells up there that could track all the way from southeastern Arkansas, northwestern Mississippi, maybe near the Tupelo area, eventually up into middle Tennessee as well. And you can also see these tracks of renegades. But the 12Z HRRR is a little bit less bullish on that cluster of renegades that develops out of southern Mississippi into central Alabama. But I think that the models, as we go through the day today, will definitely start to hint at a greater likelihood of those renegades. The 3 kilometer NAM is a little bit south with those long track supercells along the moisture nose, not as aggressive with the surge of that moisture nose. And also the 3 kilometer NAM has a bit of that cold bias at the low levels. And that's why it doesn't have that huge cape on the 29th. This is during the day on the 29th. The HRRR does a much better job with the evolution of that cape through 20Z. And you got to think that this Cape blob down here out of southeastern Louisiana into southwestern Mississippi is going to be effective at initiating those renegade storms. It's right near where those prefrontal confluence lines are located. You can see the greater Cape. Basically, these lines are visible in the moisture fields. They're subtle lines as well. And the surface-based Cape, a lot more heating to the southeast of this confluence line. A little bit more cloud cover to the west of that, which is creating a general confluence line. Southeastern Louisiana into southern Mississippi. And also this moisture nose that's surging up through the Mississippi River Valley. I think that this mode, southeastern Arkansas into northeastern Louisiana, is also going to fire a storm, and that could ride that moisture nose across northern Mississippi, eventually into middle Tennessee. But boy, does the 3 kilometer NAM keep things stable across middle Tennessee, northwestern Alabama, far northern Mississippi through the entire time period. But then you look at the HRRR, and it does have that moisture nose a little bit further north, and we'll just have to see how effective this northern nose is at generating that surface-based instability. But an abundance of Cape, a big blob of Cape, southeastern Louisiana up into middle Mississippi, could be a pretty dangerous area there, volatile for initiating those renegade storms, and an abundance of surface-based instability. A strong elevated mix layer, basically this dry pocket in the mid-levels of the troposphere here, that helps to steepen those lapse rates with the red line and generate quite a bit of Cape. And you can see a pretty weak capping inversion as well, as depicted by the HRRR. Your critical angles are a little bit shallow for a 30 to 40 knot low-level jet, but they do become more favorable with time as you get closer to sunset down within this southern mode. Yeah, those are some straight line photographs down there. You're really going to need those backed winds at the low levels, that southeasterly surface wind, to realize a significant tornado potential. There's your straight line photograph down into southern Mississippi there. You can see that this line is relatively straight, not as much curvature as you see with those really kinematically favorable setups like December 10 and 11. You had a 70 knot low level jet, so your photograph would curve all the way out here. This is more of a straight line photograph that equally favors dominance of a left and a right splitting supercell. But you do have slightly more favorable wind shear further to the northeast. Notice how that photograph gets a lot more favorably curved as you go up into western Alabama, closer to Tuscaloosa. So those storms could initiate down near Jackson, track off to the east-northeast, and eventually along the I-20 corridor, eventually arriving in the Tuscaloosa area. So I haven't decided yet whether I want to play this moisture nose and track that across northern Mississippi all the way up eventually into middle Tennessee, or do I want to play the deeper dew points down here, that Renegade confluence line, southern Mississippi down into southeastern Louisiana, eventually tracking up into central Alabama. Those are the two target areas, everybody. Thank you for tuning in to this live weather report. Do I play the moisture nose, that northern mode, or do I wait and bank on those Renegades to form southern Mississippi, eventually moving up into western Alabama? I'm going to let you know tonight when I go live. I am planning a live Q&A this evening exclusively for Facebook supporters. You can check out my post of the Ray, Colorado video below. I do have a link there to Facebook supporters. But thank you, supporters, for riding along in my passenger seat over these last 3 years, making it possible for me to live stream these storm chases and do these live briefings. And as a thank you, I'm going to do a live Q&A tonight to discuss the new models that are coming out, and also to share with you whether I target that moisture nose or the Renegades. I'm leaning toward the Renegades, I think, starting off working that I-20 corridor, maybe near the Meridian, Mississippi area, up toward Tuscaloosa, probably a little bit north of there, maybe Columbus, Mississippi, back toward Jackson, and then I'll follow that up toward the Tuscaloosa area. That's what I'm leaning a bit, but I am going to be keeping a close eye on that moisture nose as well. The helicity tracks are hinting at maybe a long track, couple of supercells that move across northwestern Mississippi, eventually into middle Tennessee. So we are going to have to keep an eye on that as well. So thank you, everybody, for tuning in to my morning weather briefing. I'm going to be hitting the road later on this afternoon, working in some new live streaming technology as well, aka another phone. So thank you, everybody, for tuning in this morning. Never stop chasing.